Hello everyone, my name is Logan. I'm a first year PhD student with the SCS laboratory at the Illinois Institute of Technology, and today I'll be talking about deriving storage insights from the IO500. Data-intensive applications are bottlenecked by storage system performance, and the IO500 is a community benchmark that stresses storage systems. On top of getting performance metrics through the benchmark, the IO500 collects details of the storage system, such as the operating system and the number of nodes. We want to analyze this data to gain insights on driving storage system designs, purchasing decisions, finding potential bottlenecks, and finding the potential benefits and drawbacks of different hardware compositions. The IO500 dataset has 57 columns and 115 rows. Submissions range from November of 2019 to July of 2020, so it's a fairly recent dataset. Institutions such as Intel, NVIDIA, and Red Hat have all made submissions to the IO500, and prominent supercomputers and cloud computers such as the Tiny2E, Oracle Cloud, Oak Forest Pax, and Frontera have all been benchmarked. The IO500 collects system information such as the operating system and kernel used for metadata, storage, and client nodes, the amount of RAM, storage type, and interconnect used for metadata and storage nodes, and the file system used for storing data, such as Lustre. Multiple issues were encountered during the data cleaning phase. Entries in various fields were not standardized, which resulted in multiple phrasings for the same thing. For example, some people wrote acronyms and some people spelled out the entire word. Multiple submissions skipped information or provided less detail than expected. For example, some used Amazon Web Services to perform benchmarks on, but they did not specify which Amazon Web Service instance that they used. Lastly, the meaning of some of the fields were interpreted differently by different users, which resulted in either incorrect or inconsistent information. For example, the amount of volatile memory. Some people reported the RAM per node and the total amount of RAM. Some people included NVRAM in their calculation and some did not. And some just reported the total amount of storage. In order to correct the first problem, we went around and standardized the entire dataset manually. For the second and third problems, we attempted to derive the correct information based off of past submissions from the same institution. If this did not succeed, then we attempted to look up the storage system online and get the correct information from there. If this still did not succeed, then we just put null entries for those values. We aim to answer multiple research questions with the IO500 dataset. Which file system and operating system is better for different workloads? What is the best hardware composition of the nodes for different workloads? How many metadata and data storage nodes are necessary to get optimal performance? And what is the minimum energy and financial cost needed to perform a certain workload? We're also happy to hear suggestions from others. If you have any ideas on what additional research questions you'd like to see answered by the IO500, feel free to email me at logan@hawk.iat.edu. In order to answer these research questions, we should be collecting additional information in the future. The types of CPU used in the nodes, the model number of the storage devices used and the amount of storage per node, the topology of the storage system, and the interconnect used to connect client nodes with the metadata and storage nodes. This all has to do with associating the design of the computer with the performance derived from the benchmark. Ideally, we would also be collecting information on the power consumption of the nodes and the financial cost of the nodes. However, this information may be considered private or difficult to collect. For the power and financial cost, this could potentially be derived based off of the model numbers for the different technologies. We're also happy to hear suggestions about what additional data the IO500 should be collecting in the future as well. For future steps, we want to include the results of SC20 in the IO500 to get more historical data. We would also like to improve the data collection for the IO500 going forward by providing more guidance on the format of inputs, better definitions of the different fields to avoid inconsistency and incorrect values, and to have new fields that describe the storage system more finely. We also would like to gather community input on additional research questions and data collection that we should be doing. And lastly, we want to continue investigating the different research questions. Okay, that's it for me for today. Thank you all for listening.